Hello, this is Greg Labarge. I'm a field specialist in agronomic systems with Ohio State University Extension, and today I want to share with you a little bit of information related to our TriState fertilizer recommendations as we use them for phosphorus management and crop production here in the state of Ohio. I want to share a little bit of background in relationship to how the TriState fertilizer recommendations came about, and then how they approach works as far as coming up with a fertilizer recommendation for the state. Basically, the Tri-State Fertilizer Recommendations are the collective research and thoughts of three universities: the Ohio State University, Michigan State University, and Purdue University, and was a collaboration of the soil fertility specialists in those three university systems. They provide a recommendation for phosphorus, potassium, nitrogen, and micronutrients for the region that includes the three states of Ohio, Indiana, and Michigan. Basically, when we talk about fertilizer recommendations, really what we're relying on in particular with phosphorus is understanding what a soil test value is and then correlating and calibrating that to yield response in the crop that we have that we want to know the fertilizer need of. In this case, a soil test really only has value to us if it can answer two basic questions. One of those is, do you need fertilizer? Basically a simple yes, no. And then secondarily, if we do need fertilizer, how much do we need in determining that rate question that we have in relationship to crop production. Basically, the tri-state fertilizer recommendations came about because we have similar soils and climates that we can rely on and use those soil test values in the three states to come up with an approach for fertilizer utilization. It was adopted back in 1995 and really focuses in on the crops of corn, soybean, wheat, and alfalfa. Our soil fertility specialists since 1995 have continued to evaluate the tri-state recommendations, and periodically they discuss the appropriateness of those for our region in relationship to crop production. Originally, that 1995 document had over 40 years of that field calibration and correlation study information from the three states that came together to come up with the tri-state fertilizer recommendations. So a very good and strong database that laid a foundation for those soil fertility recommendations. In fact, Steve Coleman, our current soil fertility specialist, went back and looked at the data that was used from Ohio's standpoint to come up with the phosphorus recommendations. He took Dr. Jay Johnson's work from 1976 to 1999 and went through those studies and found 85 phosphorus trials that were conducted over 8 sites, with 47 in corn, 33 in soybeans, and 5 in wheat. And basically what he did was used an index of relative yield, which is derived by dividing the yield of the unfertilized plots by the yield of the fertilized plots and multiplying times 100. This helps take out that year-to-year variability that we see from weather and other production factors, and helps us understand the influence of the soil test level of phosphorus in relationship to crop production. What we see there is basically once we get above a 15 part per million soil test value that we see very little response of increasing soil test value as far as that relative yield. Basically we're at that 100 line, which means that the unfertilized and the fertilized plots were yielding equally. Below that level we see quite a wide variation in relative yield based off of that lower soil test value. So the critical level we'll discuss here in detail. First, let's describe the approach that we use here in Ohio. That is a build maintenance approach, which basically looks at providing adequate nutrients to the crop and maintaining a soil capable of providing sufficient nutrients without fertilizer addition for 1 or more years. In a very simple concept, we call this feeding the soil. In other words, so the soil has enough value to it as in relationship to supplying the crop for, in this case, phosphorus. Basically what we see here is the recommendation scheme, and you have the fertilizer rate increasing, and from the X on the y-axis here. On the x-axis we see the soil test value increasing, and we see the rate of fertilizer need going from a high level to a lower level as we see that soil test value increase. We're going to really focus in on three pieces of the tri-states as far as terminology, talking about the critical level, the maintenance range, as well as the no apply zone, as these relate to fertilizer recommendations here in the tri-state region. Let's talk first about the critical level, and basically the critical level, when we're below that value, what we see is the soil is not capable of providing the phosphorus, and we also use this for potassium requirements of the crop, and thus if we're below the critical level, fertilizer is needed in order to maximize productivity. When we're above the critical level, we have a soil that does have enough nutrient in it to provide at least one and possibly more years of crop production, and we would not expect any response to fertilizer application in that case. We do have critical levels in a corn-soybean rotation, if that's what the field use and rotation is, of 15 parts per million. If we add wheat and alfalfa into the rotation, then that critical level where we don't apply fertilizer, if it's above, becomes 25 parts per million. The maintenance range is a range that goes from the critical level up to a maintenance limit, and that maintenance range basically provides us a target range for soil test level. If we're quickly going through soil test values and we see everything in the 15 to 30 part per million, we know that it is not critical that we get fertilizer down in this current production year. Basically what we do is have a recommendation that's designed to replace the nutrients that are lost through crop removal at each year. During each year, and then we also do not expect any response to that fertilizer application as far as increased yield. In other words, there's enough in the soil, but we're applying nutrients so that we maintain that soil test value. And we also do not expect a response to placement technique. In other words, when we talk about starter fertilizer, unless we're really early in the season, or when we talk about row placement in relationship to strip till or other row banded type of placements, we don't expect any responses in a yield standpoint or from a yield standpoint to that placement technique. When we talk about the phosphorus no apply zone, that's a level where we have soil test high enough that we really don't see any need to apply additional commercial purchase fertilizer. Basically, in this range, we would not expect any real yield response, really no value to continuing to build that. In fact, it's a cost for the operation by continuing to build soil test value above that 40 part per million level in the case of a corn-soybean rotation, or 50 parts per million when we talk about wheat and alfalfa. The recommendations are basically put into a table, and you see that table here. We're going to talk about that in a later video in much more detail, but gives us an idea of, via using the soil test level as well as yield goal, what kind of phosphorus need we have based off of those two factors. The table is actually a assembly of these three equations that you see here. Basically a build-up, maintenance, or drawdown equation is used depending on where we're at from a soil test level standpoint. Kind of a key characteristic to this that makes it work is that it does take 20 pounds of P2O5, which would be phosphorus fertilizer equivalent, to move up or down the soil test level 1 part per million. In other words, if we apply fertilizer and do not have a crop there to remove it at a rate of 20 pounds, we would expect to see that soil test level go up 1 part per million. If we remove a crop and do not replace the nutrients that were taken off, we would expect for every 20 pounds that we remove that the soil test level would go down 1 part per million. This is kind of a working example of that. It shows the removal rate of some of our various crops that are included in the tri-states based off of either bushels or tons of yield. You see the 2013 Ohio yields for each one of those crops, and so for example, and then in the final column you see the removal rate is pounds of P2O5. So for example, the corn removes 0.37 pounds of P2O5 per bushel times 174 bushels. Our 2013 crop on average here in the state of Ohio took off 64 pounds of P2O5. The next graphic here, if we don't replace that value taken off by the crop from a fertilizer addition standpoint, how much do we expect soil test values to change? And what we find is that we have a pretty highly buffered system here. Our 174 bushel corn crop would only move without additional fertilizer our soil test value in and of itself about 3 parts per million. The highest would be corn silage at 5 parts per million. And so really when we talk about that target range of 15 to 30 in the corn soybean rotation, if we're at 30 parts per million and we then remove this kind of standard crop yield, we're only going to see that drop to about 27 and still be far above that critical level where we know we absolutely need to apply nutrient in order to maintain crop productivity. Once again, kind of a buffering in that system, and starts to explain that soil capable of supplying nutrient for 1 or more years. So once again, the recommendation approach that we have here in the state of Ohio is a build maintenance approach, feeding the soil so that the soil is capable of providing nutrient to the crop over the long term. And what we see here is the different values that make up kind of those key numeric soil test values we want to look for. The critical level of 15 to parts per million with a maintenance range for corn and soybean of 15 parts per million up to 30 parts per million. Recognize these are all in a Bray P1 soil test value. And then we also see that the no apply zone for those two crops are 40 parts per million, where we don't see any real agronomic benefit to applying commercial fertilizer at that point. Then you also see where if wheat and alfalfa is included in the rotation, that we do have a 10 part per million value increase over all of those levels. So in summary, our TriState fertilizer recommendations are the Ohio State University recommendations that we use to provide to growers here in the state of Ohio. It relies on a representative soil sample taken and analyzed for phosphorus with a Bray P1 extractant or equivalent test. It uses a build maintenance approach where we feed the soil, and then the soil is capable of providing nutrient to the crop throughout the growing season. The critical levels are that point where we talk about yes or no, we do or do not need to apply fertilizer. If we're below 15 parts per million in a corn soybean rotation, or below 25 when wheat or alfalfa is included in a field's crop rotation, then we do want to apply fertilizer in order to maximize yield in that year of production. I want to make you aware that we do have 2 more videos in this series that you'll want to take a look at. They follow up on our recommendations approach that we were just talking about here, and cover reading a soil test report for phosphorus values, reading that soil test report and getting the right information off of it, and then a exercise 2, which is developing a nutrient recommendation utilizing the TriState fertilizer recommendation tables. Hope you will join me for those 2 videos here in the next